Okay, good day, students. This is one of the first video recording with the course CSC 3315, which is Object-Oriented Programming. This is for the first semester 2022-2023 academics. My name is Dr. Armaya'u and I'm the course lecturer for this course. Just for your information, we were directed to start virtual training, part of which is recording this lecture series, and then we, of course, schedule a Zoom meeting so that we can clarify any gray areas that you don't understand in this lecture. But you should know that you come back on campus after these elections and CWAs. So we're going to carry on where we stop. So basically, when you come back, we'll be taking you on practicals and demonstration, and also we'll cover the rest of the weeks that we ought to have covered. But we are not going to have semester extension. So that's why I will appeal to you to make maximum utilization of these videos and take note of what you don't understand so that when we come on our virtual interaction, you ask your questions. So this is the course outline for CSC 3315. Of course, I will take you on introduction of object-oriented programming and then how to identify objects and how to model them. And these are essential elements of object-oriented programming, that is class, attribute, and method. To go deep on them in this course. I'll also look at the concept of encapsulation. I'm going to look at string as objects, array as object, data structures, inheritance, polymorphism, and design patterns. So last year, that is where we stopped because we couldn't cover the rest of the three topics. So this year, I'm hoping we should be able to cover object-oriented frameworks, limitation of object-oriented programming, and also recurring. So very quickly, I will recommend you get these text materials. I have them. I will share with you on Google Classroom. I will encourage every one of you to join the class. The first one is Head First Java. The second one is Head First Design Patterns. And also there is a book called Objects First with Java, a practical introduction using J. So BlueJ is actually an integrated development environment or ID for learning object-oriented programming. Of course, I want you to download it and install it, and also install any IDE of your choice because you need to have, you need to be practicing this actually in order to reinforce what you may learn in this lecture series. So introduction, traditional imperative programming language, as you know, most of the programming language we use are classified as imperative because they actually enumerate commands on what to do. So they are basically influenced by the way conventional software architecture is, and that is called von Neumann architecture. So von Neumann architecture has a memory outside processor, so they use what is known as fetch execution cycle. So if instruction is to be processed, it has to be fetched from the memory, and then it's executed in the processor. And if it's going to be stored in secondary storage, it's then going to be sent to that storage. So that actually largely influenced the design of imperative programming language and also teaching them. So teaching programming language traditionally has been based on variable, because that variable resemble memory location where this data or instruction is being fetched, and sequence of execution or selection and iteration. But conventional teaching programming also has been governed by the design and implementation of algorithms and data structures. That is, the emphasis has been, okay, these are the algorithms that we need to be that need to be translated into a particular programming language, and that has been at the major focus of teaching programming conventional approaches. And again, to summarize, the traditional teaching method, because it's focused on algorithm and data structure, somehow some people are saying, okay, programming is algorithm plus data structure. But in object-oriented programming here, we are by laying emphasis on a different thing. But just to re-emphasize, in conventional programming, emphasis has been on synthetic details and structure of a language. But in object-oriented programming, we focus on the problem solving rather than the language details. That is, we try to identify objects that interact to solve a particular problem, and then we code our software around those objects. We continue with the introduction. We said object-oriented programming was developed out of the desire to manage complexity and improve productivity. Initially when software was being developed, that was the initial inception of software engineering itself. The programs being developed were not really complex; they were simple. So they didn't need really a particular code structure. But then the software being developed started to become very complex. Then they started to begin to look for ways to manage that complexity. And in the search of ways to ease that complexity, then object-oriented programming came into being. So it is a programming style that uses real-world object design computer programs. So the computer programs is a direct translation of some kind of objects in real world. So in that way, it reduces the conceptual gap from the design surface to the implementation, because the program is a collection of object interaction to achieve common goal. So you can mentally visualize your program as a collection of objects. So in that sense, it's we can say it reduces the conceptual gap from design space to implementation space. Object-oriented programming also provides additional support for code reuse to inheritance, so you can reuse actually the existing code as with this inheritance mechanism. We'll go deep in this later. It also supports additional flexibility to polymorphism. So actually, if you want to develop a software that can be used in many different contexts, or that can support different set of features. So actually, polymorphism is good at that. With OOP, if you are professional software developers and you are using OOP style, so you tend to get a lot of support. Some of which include unit testing framework. So for example, these days people focus on writing tests before actually writing the software code. So that approach is called test-driven development, and it's supported by unit testing frameworks. Again, one way to get a support as an object-oriented programmer is through using object relational mapping technology. So it means from the object you identify in the programming, you can actually map them into a relational database if you're using database at the back end. So you can also reuse design patterns. So because people have been programming for a long time, and some of them are actually experienced object-oriented development. So they experience problems and they solve them using object-oriented pattern, and they share those patterns they use to solve those complex problems. So you can actually reuse those patterns if you have similar problem that you solve. Again, yes, there are some tools and support for refactoring. Refactoring actually is changing the structure of the software without actually changing functionality of the code. We do that because we want to make our software code become more maintainable. So we want to organize it neatly. So that is called refactoring. So the principle or the building blocks of object-oriented programming are object and classes. So object and classes, they are related. So yeah, so if you are writing a computer program and object-oriented programming, you are actually creating a model of objects that appear in the problem domain. Problem domain here is a particular area in which you are developing software. So for example, before we get to example, we need to take off on what class is. Here we say class describes all object of a particular kind in an abstract way. That is a kind of generic generic description of a particular kind of objects. So for example, if you say a student, you can think of it as a class that describes the following objects: Modus, Arimi, and Fatima. In a way, we are saying the class is the abstract description of Modus, Arimi, and Fatima in this context of them being students of the university. One thing to note here is student is general. But let's say we have a name, Ibrahim Modus Arimi. Honestly, this is a mistake. I wanted to say Modus Arimi. So Modus Arimi in this case is specific. So we say the class is the generic description of a concept, while an object is the specific instance of that class. So we say student is a class, and okay, this is the repetition. So in OOP terminology, we say an object is an instance of a class. In this case, Modus Arimi or Fatima Muhammad are instances of a student class. So before you even begin to think of developing software using object-oriented programming, you need to analyze the problem you want to solve in order to identify objects. And that way it's even faster, because otherwise you may end up starting to develop the program and then you get confused and then you will have to start all over again. But with the identification of object first, and you will have a clear guideline on how to go about the developing software. So, and again, finding the objects and deciding what task to allocate to those objects is not even a programming job, it's a problem solving job. So you need to identify those objects and think of the responsibilities that should be assigned to those objects. So in this case, we are looking for answers to questions like, what will the program achieve when it's completed? What classes and objects are needed to solve the problem? What will be the responsibilities of those classes and objects? And what will be information, content, or functionality of each object? In a way, this is where we put data structure that the software manipulates. How will the object handle their responsibilities? How will the object communicate? Because if you have plenty of objects collaborating or communicating to achieve a common goal, then you need to define how they will communicate. So very quickly, we begin to have a concrete example. So here we are setting an example of an information system, which it's a trivial, but it will show a lot of things that need to be looked at. So let's say we want to automate a problem of manual picking of an appointment with a dentist. In the manual process, a patient calls the dental cleaner and say, hey, I'm Modus Armin, I want to book for an appointment with the dentist. And then most likely the receptionist of that dental clinic will receive the call and say, look at the schedules of available slots for booking, and then guide the patient on which slot is available and which one is not. And then maybe from the conversation on phone, the patient will select one of the available slots, and then the receptionist will read up and inform the patient of the appointed schedule. So let's assume that the patient has already registered with the clinic. So the assumption here is the receptionist knows exactly who that patient is. So now, if we want to identify objects here in this problem, because we want to develop software to solve this problem, some advocate the use of noun or noun phrase analysis. That is, in this scenario I explained, you begin to look for noun or noun phrase. For example, dentist, patient, receptionist, all these things, all these are either nouns. So from that, we can develop what is called a domain model. So that's why I put this in boldface, dentist, patient, receptionist, because they are the key objects or classes in this domain. So we may also decide to use a use case model to even explore the domain, because we want to identify this object, not only the object, or how are they related and how do they interact in the problem, so that we can develop software to translate those functionalities. Uh, so domain model is a representation of the conceptual classes in a problem domain, and it's a representation of real-world conceptual classes, not software components. So here we are not even talking about software, because we are not there yet. What we want is the kind of model of objects or classes that can eventually translate into software code. For a very complex and large domain, it helps to understand what you were even planning to develop. For trivial problem, you don't need to do that. You simply start coding right away. But in a complex programming, if it's a large software and complex, then you need to do that in order to identify the domain's objects or the domain classes and how they interact. It eases communication, and it also can also show a relationship between classes. For example, here we have patients, and it's been allowed to put some of the key information that will help in developing this software. For now, we call them information, but technically these are called attributes. So a patient may have an ID and name, and then there can be slot. Slot here is also a class. Patient here is also a class. Slot here is a class, but you can see slot here is a class, but it's software class. It's not physical something. Of course, you can see the slot, but here where I mean is logically slot is also a class. So from slot, we also have a class book slot. So here we say in the book slot, we have slotting. That is in this class, it contains slots. So book slots contains slots. I don't want to confuse widely enough in this course, but this is called composition, because this class book slot is composed of a slot. But book slot is also composed of dentists. So we have patients, we have slot, we have dentists as classes. But book slot is a class that composes other classes. In this case, it composes slot and dentists. So this model, a use case model, remember we said we can use it to explore the problem and to have better understanding of how to solve it. So it describes software product from the user's perspective, and it represents only the high-level functionalities. So there is a software engineer, is a Swedish, it's called Eva Jakobsson. It's actually the one who popularized use of use case diagram in late 80s and 90s. It's interesting to know that Eva Jakobsson is still in the software engineering industry. He has a company known as Jakobsson International. They do software consultancy services across the world. So here in the use case, we analyze the host system to identify every single functionality, and we then transform those functionalities into use cases to be used in the use case diagram. So we will begin with the elements of a use case. A use case have one or more actors, which represent an entity that performs certain roles. For example, students, dentists. In that very example we are citing, so we can say dentists, patients, they are all actors in this system. And we have a use case, which is a representation of a distinct functionality in a system. For example, reserving slot. But reserve slot is also is a use case. We have system boundary, as actually we don't have its illustration here, but I'll show it to you maybe in the next slide. It shows that what the system covers and what is actually outside the system. So we have include relationship when a certain use case use the functionality of another use case. I'll show you an example. A reserving slot, there is receive confirmation use case. So when the slot is finally reserved, it will send information to the patient to receive the confirmation that the slot has been booked. So we can say a reserving slot includes receiving confirmation use case. So we also have an extend relationship. Extend relationship, I want to drag this around. Extend relationship is when the relationship is like child-parent relationship. For example, here viewing slot, such slot. So we can say such slot extend view slot. You can actually basically, this is the basic use case or the basic functionality, which is being slot. But if the functionality to search for a particular slot is available, then it's an extension of viewing slot. And we also have generalization relationship, which is also a parent-child relationship, but it presents like a kind of narrowing scope. For example, here when we say receive confirmation, it's a general use case, but receive text message confirmation is a specific or specialized use case of receive confirmation. So because we can also have receive email as a way of receiving confirmation. So here it's an additional explanation on this generalization relationship. Here, maybe if you know the symbol of object-oriented notation, this is inheritance symbol. It means receive text message inherit from receive confirmation. But actually it's specialization because the child use case specialize on functionality it has already inherited from the parent class. So if we think of this receive confirmation as the general use case, we can say receiving the confirmation via text message is specialization of receive confirmation. So now we can put things together. So this rectangle, if you like, it's the system boundary. So these are the actors: patient, scheduler, dentist, and then these are the use cases here. So the scheduler populates available slots. Maybe they take when the dentists are available, and then they have a list of schedules that are bookable. And then the dentist may view slots, and then also the patient as an actor can slot. But remember, we said such slot is an extension of view slot. It means you can view slot, and in addition, you can search or filter for a specific slot, maybe on a particular day or on a particular time. Because basically, if you're implementing software, this view slot has to be available before you begin to think of tailoring such slot. And then the patient can select slots, and that may include reserving slots, can include selection, or definitely include selection slot. The slot has to be selected for it to be reserved. And then reserving slots will have to include receiving confirmation. That is when the slot is finally reserved, the confirmation is sent to the patient. So we say receive confirmation is included in the reserving slot. And receive text message and receive emails here are specialization of receive confirmation. I will encourage you to explore this use case model. Again, information is widely available on the internet, but I have a book, I have a reference book that I will share with you at the end of this lecture. Sometime the diagram, the use case diagram of just showing you in the previous slide is not enough. You may have to add description and scenarios, post condition and condition, simply because you want to explore. Sometimes doing that will export a lot of things that may otherwise be overlooked. Uh, so this is actually what's the template for use cases may look like. So first, you have a use case name, place of actors, group description, trigger, event, scenario. Actually, I will give a concrete example of all of this. So we have the example of use case description for populate slot. So the use case name is populate slot, and the actors, we have only one actor, which is the scheduler. The group description is populating slots to make available for picking. And we have triggering event. Which event would trigger this use case? Maybe shifts, new shift is available. Maybe an dentist is available for booking, maybe add slot. So scenario, how does it operate? Or what is the sequence of populating this slot? Or what is the sequence of executing this use case? Actually, we begin by assigning an ID to the slot. We assign the time to the slot, let's say 8:30 in the morning or 8:30 in the evening. And then we assign one of the available dentists, because even if you have the ID, you have the slot, you have to have the dentist that will man the slot. So exceptions, these are the unusual things or the alternative path to this scenario. So for example, if you assign or you schedule a dentist for more than once at a time, because physically a dentist cannot be two places at the same time or cannot be attending to a patient at the same time. So this is wrong and sure is an exception. Or maybe you attempted to specify the time this slot outside working hours. Also here, an exception should be raised. So we don't have related use case here, but we have to condition that a shift must be available for this use case. This condition specify that an appointment slot need to be stored in permanent storage. Here, you may notice that we didn't mention anything like database because we don't want to be tied to like implementation data. What we want here is to understand. Again, this is a reserved slot. You can go with this on your own. So apart from use case diagram, we can also use an activity diagram to explore the problem. This is simply to understand the problem better before you even begin to code. So here, if you remember this class, I think in 111 version problem solving, I taught you this activity diagram. But these are purely the symbol, initial node, final node, and this is the activity. An example of an activity is arithmetic. We have action, and its example, we have control flow. So for example, this is an activity which is called arithmetic. And within that activity, the beginning symbol and control flow, and then we have an activity of adding two numbers, and then we have a control flow, print the result and get to the end. We have decision and match. Yeah, if you know, we say decision. The difference is that for the decision not one control enter it and two control leave, while for the match not several controls flow into it and one control leave. We have another difference between decision and merge node is control flow leaving a decision node will have to have a guard. You can go back to your lecture on integration flow and solving to refresh on this activity diagram. But this is to put things together. We have an activity here. So we have a decision symbol. A decision has two guards. The first guard here is checking if the balance is, if the amount user selected is less than the balance. And if that is the case, then this otherwise this printing solution font will take place. So you can see this is match. So here one control is entered into this decision and two are leaving. But in the case of match, two are coming in while only one is leaving, and then it's here. So we have fork and join. Because fork donates the beginning of the parallel activities, while join join the parallel activities together. This is very similar to match and decision. And again, it's better if I can show you an example. So this is a decision. If card is inserted, here we are simulating ATM machine. So this is the card is inserted, and this is no card is inserted. So we have a fork point here because it's the beginning of two parallel activities. Here in this case, because we are splitting the ATM machine, the ATM machine can blink the real light and also play music at the same time. But then when card is inserted, so then we have the join here, and then take they will check on this decision and then proceed with doing something else. So why we are even reviewing activity diagram? We are reviewing activity diagram because we want to get to swimlane activity diagram, which is a kind of a type of activity diagram that partitions responsibilities, uh, uh, like partitions the activities in lanes, and each lane is being responsible by one particular class or object. So, for example, here we can say we can partition these responsibilities or these activities of the activity diagram into those that are that the system is responsible and those which the patient is responsible. For example, here is the beginning. Displaying available slot is the responsibility of the system. From there, you get to the selection of one of the available slot, which is the responsibility of the patient, and then we come back to decision, and then until you get to the end. So we can have an idea on what classes or object we need for our software and how do we assign responsibilities to them. So even exploring more, we can use what is called class responsibility collaboration cards. So this was invented by a software engineer also known as Ward Cunningham and his colleague Ken Park. They use it as an approach for discovering and documenting object-oriented design. It's used in professional software development such as agile STM programming. Maybe you don't know agile software programming, but anyway, if you don't know, never mind. I'll get to that some other time. So remember, we said a class is represent a template from which similar objects are created. So here in class responsibility cards or CRC card in short, we redefine this the concept of class and the responsibility. So we say a class represent templates, and this is as the way we know it. Responsibility is something that class knows or does. So mark this. So we identify also the responsibilities for that class, and the criteria for identification of those responsibilities is if the class knows something, we say it is the responsibility of that class. Or if it does something, we say what it does is the responsibility for that particular class. And collaborator is another class that the class interacts with its responsibilities. Often a class cannot fulfill its responsibilities on its own. It needs the support of other classes. So we list all those classes. And so again, this is we're simply saying how the CRC card looks like. It's an index. It looks like an index card. We put the name of the class, and then we list the responsibilities, and we'll also list the collaboration. I'll give you a concrete example. So here is the CRC card for the dental system. The fourth card represents patient class, and that's why we put the name patient here. And these are the information either the patient knows about or it's the patient class is doing those things directly. For example, ID, the patient knows about his ID, knows about his name, knows about his previous appointment, future appointment, cancel appointment, miss appointment. But these are some of the things this class does, like search for appointments, lot of request for reservation and cancellation. But in doing that, it may have to, or it requires another class. And in this case, that's why we list it here as one of or as the collaborator function. We give it a name, dental booking manager. So what I want you to know that a class doesn't have to be something that exists in physical world. It can simply be a kind of maybe logical class that only exists in the world. In this case, dental manager, maybe it doesn't exist in the world. So the dental physical booking manager should know about available book slots, and maybe populate appointment slots, process booking requests, process cancellation, and maybe by doing that, it requires other classes such as slots, book slot, patient, dentist. And the book slots, uh, these are the responsibilities and these are the other collaborators. For the dentists, for the slots, these are the responsibilities and this is collaboration. For the dentists, it doesn't have maybe any collaborator here, but these are the responsibilities. Which is basically the information that the dentist is aware of. And this is the dentist name and dentist rank. So anyway, I will stop the recording here, and the next recording I will show you around integrated development environment.